Hi, everybody. Welcome to ES 2410 Mechanics of Materials. Today I'm recording a brief introductory lecture where we're going to take a look at our Moodle page, and we are also going to take a look at the syllabus, and I'm going to show you what you need to do to succeed from this point forward. Um, the first document that I want to take a look at is the Moodle page. And let me share this with you. All right. So when you hit your student portal here at NWC, you will see a place that says online courses. And since this course can be either an online or a hybrid course, meaning that you can do everything without meeting with me face to face, excuse me, or you can meet with me one day a week face to face and do the rest of the work on your own time, and then come to me if you need help. That you'll have a Moodle shell. So the Moodle shell is under the online course tab on your student portal. And basically, I keep this organized with all of the material that you will need in order to be successful, so that whether you take this course as a hybrid or you take it as a fully online course, everything is available to you here. Now, the first piece of information, and one of the most important things, is um, the introductory lecture, is the course syllabus for the spring of 2026, which is right here. This tab, the introductory lecture for the spring of 2026, is actually what we are doing right now, what you and I are doing today. So, in other words, if you hear anything today that is not familiar to, or you need to have your mind, you need to be refreshed in terms of some sort of a memory, you can always come back here and listen to this lecture at any time, and then you will have access to that material. So since the syllabus is so important, that's the first thing that we're going to take a look at. We're going to go through this document so that you have all of the information that you need in order to be successful. All right. So first of all, like I said, this is ES 2410, 1H, which is hybrid, and 1N, which is fully online, Mechanics of Materials. If you are in the fully online course, everything is asynchronous and available through the Moodle page. If you're hybrid, we meet Wednesdays at noon in Math and Science Building 120, which is directly across from my office. My office is SM117, and you can reach me by dialing 754-6066, or you can reach me by email. The other thing is, I will have my office phone forwarded directly to my cell phone, and my cell number is 307-272-1833. And you're always welcome to call me on that phone. It's best if you don't get a hold of me to leave a text. Please don't leave a voicemail because I don't pick up my voicemail. So if you text me, I'll get back to you as soon as I possibly can, which generally doesn't take too much time. So the other thing is, here we go with this. This will be the Zoom link where we can meet for class, or for other if you need extra help, we can meet through there, or you can go to Calendly and set up an appointment, which will automatically generate another Zoom link, and we can visit at any time. I do not keep regular office hours like Monday, Wednesday, Friday from 2 to 4, because since I'm division chair as well as instructor here, I'm always on campus. So it's more like an office job. So you're welcome to stop by my office. You're welcome to set up a Calendly appointment with me, or you're welcome to send me a text, and we can get you squared away, hopefully in a very quick amount of time. All right. So once again, the Moodle page on the student portal is our class website. So I tend to refer to those two things interchangeably. This course has as a direct prerequisite statics, because we build on statics right from the beginning. And so it's a functional prerequisite, meaning that you need to have the material that we did in statics in order to succeed in mechanics of materials. If you have any problems with that, please let me know, and we will take care of it right away. A catalog description is mechanics of materials is an analysis of design of members subjected to various types of loadings. That includes the mechanics of deformable bodies. Now, if you remember, in statics, we didn't really talk about it very much, but we implicitly agreed that the bodies that we loaded, the bridges, the trusses, the boats, um, the transmission towers, the hot air balloons, that nothing was going to fail, that everything was strong enough to bear the load. So in this class, we entertain the question, what if it's not strong enough? What if it won't bear the load? So we look at where things fail and how they fail. So it's a little bit more in depth. We do a whole lot more two-dimensional work as opposed to the three-dimensional work that we did in statics, but we look at things inside instead of just from the outside loading point of view. What we hope to accomplish and what the successful student will accomplish is to gain factual knowledge and learning of fundamental structures and designs, and to develop skills and proficiency necessary to analyze and solve basic structural design problems. You also develop the thought process and methodology required to interpret, analyze, and solve engineering problems to the level and in the manner that will be required of the student from this point forward. So what that means specifically is that you will be doing problems on engineering comp paper and that they will be in very, very nice format. And that means a free body diagram and all of your equations spelled out and all of your work put together well. Now, this doesn't depend on you having beautiful handwriting, because I can read some pretty gnarly handwriting. However, it does depend on you doing everything and being very explicit. So I know that many of you are good enough at math that you can do a lot of this in your head, and so can I. But that's not what you're being evaluated on in this class. You're being evaluated on doing this the way an engineer is expected to do their work. And so that's why we lay out problems in this very careful and precise manner. So that's what we'll be doing from now on. And if you have any questions about that, I will clear them up as the semester goes on. And I also make comments on your homeworks that will indicate what you are doing correctly and what you are doing incorrectly. So in addition to using the paper, you will have to have a textbook. The textbook that we're using is Mechanics and Materials by Beer and Johnson. And this is the 7th edition. I do not insist on the 7th edition. You can use a lot of different editions of this textbook. But the only thing is when you have the problem set, you need to make sure that you choose the problem set from a single textbook edition. So in other words, don't cherry pick. If you're working from the 6th edition, get all of your problems from the 6th. If you're working from the 7th, get all of your problems from the 7th, and so on. All right, so the next question is, how will you be graded in this course? And it's very much, for those of you that have taken courses from me in the past, it's very similar. Your homework assignments will be worth 10% of your final grade. There will be 9 homework assignments in this class. There will be 2 quizzes in the class, which are also worth 10% of your grade. And there's a midterm exam, which is proctored 2-hour time block, 40% of your grade, and a final proctored 2-hour time block, 40%. Now, if you are here on campus, I can proctor you. If you are somewhere else, if you're at another college or another location, you and I can visit and we'll make arrangements for the test to be proctored for you. But in any case, everything else is sort of on your own. You can use other sources. On your homework, you can work with your classmates. Your quizzes you need to take by yourself, but it isn't closed book in any way. You can use resources that are available to you. But on the midterm and the final, I will help you construct a formula sheet that you write out in your own handwriting and then bring into those exams with you to help you. But it's not open resources except for the formula sheet. Okay, so based on those 4 elements, homework, quizzes, midterm, final, if you get a 90% average overall, you're guaranteed an A in the class, 80% guaranteed a B, so forth. Now, if you get close, if you got an 89.6, I reserve the right to round up. So if you got an 89.6, you might get an A, you might get an A minus, you might get a B plus, or you might get a B. Probably not. You'd probably get a B plus, A minus, or A. However, I never round down. So in other words, if you have a 90.0000 and everyone else in the class has 100, you still get an A. So I guarantee those lower limits, but I reserve the right to extend the lower limit a little bit based on the nature of what we're doing in the class and your work overall. This next point is very important. All of your homework has to be scanned and submitted through Moodle. I don't take any email assignments, and I don't take any handwritten, handed in to me assignments. Now, your homework will be handwritten, but after you do it on the engineering comp paper, you need to scan it and submit it through Moodle, preferably as a PDF. I can take a JPEG, prefer the PDF, but I cannot take any format, for example, the HEIC format that comes from taking a picture of an iPhone. So if you have an iPhone and you take a picture of it and you send it to me through Moodle, I won't be able to read it, so I will send you a message saying I can't read it and you'll have to redo it. All right, so if you have any other concerns about what's going on here at Northwest College, this link, the universal syllabus information, will fill that in, and that's not just for this class, but for any class at all. All right, so that's kind of the basic of the syllabus. Now let's take a look at the Moodle page and the schedule for this class so that you can see what everything is going to look like for you and how you're going to be the successful student that we both want you to be. So first thing is you'll watch this lecture, which you have to here. If you need to meet with me, here's a Zoom link. If you need help, schedule an appointment with me. That's that Calendly link. Course syllabus, we just went over that. Homework template. Well, let's take a look at this. All right, so this homework template is actually a standard form of how engineering problems are put together. And you can see at the top, you write the due date, the course number, your last name, your first name, and then how many pages of the total. The way I collect homework, I don't collect it after every section. I only collect it at the end of a chapter. So this, you may do this in several parts. Like if, say, chapter 3 has, let's find out. Chapter 3 in my version of the textbook has, well, it has 10 sections, but we only cover 5. So let's just say that you have 5 sections. Maybe you have a homework assignment after section 3.2 and after 3.4 and after 3.5. All of those are together in one homework submission. So the number of pages you have is going to be quite high, and you're not going to know it until the very end. Maybe your first homework, you have 3 pages, then 2 pages, and then 2 more pages. So that's 3 plus 2 plus 2, which is 7 pages. So the bottom number here would be 7, and then this would be whatever that page number is as you put them in order. All right, so you write the number of the problem, you identify the problem, you do a sketch or a free body diagram as appropriate. You list the theory or principle used to solution, you list any assumptions, and then you do the math. So in other words, there are 1, 2, 3, 4 steps before you do the math. If you just do the math, you will not get full credit. You'll be sorely disappointed in your grades. So please go through the steps. Then you write the answer, must have the proper number of significant figures. Do not write something with 8 decimal places if the data only had 2 decimal places, for example. But you should know how sig figs work, but if you don't, I'll be happy to work with you on that. But then separate it somehow. I like to put the answer, which is numbers plus units, off to the side, and then to separate the problems with a line. And that's why there's not too many problems in every homework set. In some classes, like in math, you might have many, many problems because they're quick. The problems in here take a long time and they're multifaceted, so you will not have that many problems in your homework sets. I mean, comparatively, but they'll still be quite lengthy in terms of how long it's going to take you to complete them. All right, let's go back to the Moodle page. All right, what I have here is the weeks leading up to midterm. So in other words, there are 7-ish weeks, and then our midterm exam, and then spring break. And then you'll have another schedule like this for after spring break. But in week 1, which begins on January 13th, you watch videos 1, 2, 3, and 5, 1, 2, 3, 4, and 5, and then you do the homework review. The homework review talks about the method of sections and the method of joints, which we did in statics. I just find that a lot of students are not really comfortable with that material, and they're not ready to just hit the ground running. So chapter 1 kind of starts out like, you know how to do sections, joint, method of joints, method of sections. So let's start there. I just found students stumbled, so I put in another section with a review. So your first homework is going to be that review sheet. And it's just some homework, it's some problems, method of section, method of joints problems that you will turn in to me by the end of this week. So in other words, where it says something is due, the due is by the end of the week. This day is the beginning of the week. The homework is due by the end of the week. So by the end of this week, you'll do the review. By the end of next week, you'll have homework number 1. Then 2 weeks later, homework number 2, followed by the quiz. Then homework number 3, homework number 4, and then the midterm exam, which we'll schedule for during that week. But this gives us plenty of time to get everything done. Now, a couple of points. The weeks lay out the videos. The videos that are identified with number sign, like this, lecture number 2, with the number sign, those are required viewing. Okay, so what that means is we're not having lectures in class because those are the lectures. So if you don't watch the videos, it means you have missed class and you won't be ready to proceed. So you need to watch the videos, and that's why I put them on the schedule this way. These videos will prepare you for these homeworks. So getting back to our first section, in week 1, you're going to watch 1, 2, 3, 4, and 5 videos. 1 is this video, by the way. Then you watch 2. There's some additional material that can be interesting. And then 3, 4, and 5 are the required ones. These can help you, and these are not videos. The only ones with links are videos, but these are just like pieces of paper that show you something, or a picture that shows you something that can be helpful to you in your pursuit. But the big deals are the ones with the number signs. Okay. So what's your homework for the first, the review that's due at the end of the week? There's a handout for homework part 1, handout for homework part 2. So you will open this up and take a look at this material. Okay, so this tells you analysis of plane trusses by the method of joints, some examples, how it works, and so forth. And then you come down here and you see that we have problems starting with number 10, 11. So it's 6.10, 6.11. Those chapters are from the statics textbook. Okay. Then you open up the second handout, the second part of the handout, and do the same thing. Okay. That's the material. Now, when you do your homework, the way that you find out which problems are your homework problems is you come down here to the tab that says Submit Review Homework, Method of Joints, Method of Sections. Okay. And when you open that up, what you'll see is here are the homework problems, 6, 14, 15, 30, and 33. So every time that the word submit comes up, what the word submit means for you is that's where you're going to turn something in for me that I'm going to grade, that's going to become part of your final grade. And it always tells you exactly what it is that you're going to turn in. Okay, so there's only 4 problems from those handouts. And when you get, there's 2 method of sections, 2 methods of joints, and you get those done, and then you're done with your homework review and you're ready to move on to homework number 1. So continuing with our discussion, we're almost done here today. But so every time you see the word submit, one of my students a long time ago said, submit for success. And I've always remembered that because every time the word submit comes up, your success is based on you submitting something. So that's where you'll submit that PDF or in a secondary possibility, a JPEG of your homework assignment. Okay. So that's how you succeed in this class. Now, the next section is going to be where we start with chapter 1. I do have a posting of the textbook in case it takes you a little bit of time to get the textbook. I also have the PowerPoints, and then I have the lectures. So for example, if you're looking at the lectures and you cannot clearly see the PowerPoints, or if you want to supplement with the PowerPoints, you can just pull this open and have it open on your computer at the same time. Then submit homework number 1. I have everything posted, chapters 1, 2, 3, 4, include the review 1, 2, 3, and 4. So that's 5 homeworks plus the quiz, which is right here. Now let's talk about the quiz for just a moment. You open up the quiz here. You take the quiz on engineering comp paper. You take a picture of it and you submit the quiz here. In other words, you do not submit the quiz in the same place that you open the quiz. You open the quiz, you do it on paper, take a picture of the paper, and then submit it to me here. All right. So I have everything open, chapters 1, 2, 3, and 4, and then a little bit of preliminary information about our midterm exam, which will be held between March 2nd and March 6th. The following week is going to be our spring break. And during or before or during spring break, I'll open up the rest of the material, which are the rest of the chapters that will be required for this class, or be required in order to succeed. All right, students, that is it for mechanics and materials. The message I want to leave you with is, in order to be successful in this class, please do your homework and your quizzes, take your midterm and your final. And when you have questions, please ask me. Since we don't have a regular 3 hours a week class period, it's important that you reach out. That's what I'm here for. I'm here to help you in your pursuit of of knowledge of this material. So when you have trouble, do not hesitate. Do not hesitate to get a hold of me. I'm happy to help, and I will be able to get you back on the right path, squared away in short order. But watch those videos, look at the PowerPoints, do the homework, ask me questions. All right. Well, I hope you have a great day, and I'll look forward to seeing you in class, whether it's online or face to face. Have a great day.